Read before changing. That is the rule for this video. When the Claude workflow fails, do not start by rewriting the prompt. Start by reading the trace. Because until you can prove which layer owns the failure, every decision change is a guess. In Module 2.1, we learned the anatomy of the Claude API response. In Module 2.2, we wrote the on-response state. In Module 2.3, we added the safe control: continue, retry, stop, or escalate. Now we add the discipline that keeps all of that from turning into a random fixers. Trace first, lever second. That is the core idea. When something breaks, your first question should not be, what can I change? Your first question should be, what did the system observe? Then, what did the application do next? Then, which layer owns the decision? If you cannot answer these three questions, the change is not debugging, it is guessing. This matters for the real system, and it matters for the certification exam. Exam questions often give you a symptom, then offer plausible fixes, a stronger prompt, more retries, a strict schema, a better tool description, more context, a human escalation path. Some of these fixes may be real, but the question is not whether the fix is real. The question is whether it owns the failure. A real fix can still be the wrong fix. A stronger prompt is real. More lies are real. More schema constraints are real. A better tool boundary is real. But none of these are automatically the correct lever. The correct lever is the smallest reliable change at the layer that owns the observed failure. So the weak debugging is this: symptom, favorite fix, hope, pray. The strong debugging path is this: signal, layer, lever. What signal did the trace show? Which layer owns the signal? Which lever changes that layers most directly? That is a debugging version of the answer ranking. Now let us define a useful trace. A useful trace doesn't need to expose everything. In fact, it shouldn't expose everything. You do not need to dump private documents. You do not need to log secrets. And you do not need to preserve full raw inputs when a safe summary is enough. You need the smallest evidence set that lets you reconstruct the architecture decision. For this layer, you need to capture the case identifier or trace identifier, the API request identifier when available, the response identifier, the stop reason, the content block type, the usage number, the tool signal or validator signal, and the chosen next action. That is enough to answer what happened, what branch ran, what layer owns the result, and what should the system do next. Useful logging is not maximum logging. Useful logging is decision evidence. Now separate two failures that people often belong together. First failure: the stop reason is tool use, but the application returns final text to the user. That is a routing failure. The loop branch is wrong. The tool received a tool use state and treated as a final completion. The owning layer is the router. The fix is to route correctly on stop reason and content blocks. Second failure: the output is shaped like JSON. The fields are present. The structure looks valid, but the tool is wrong, or the line items are incomplete. That is not a routing failure, that is validation failure. The owning layer is schema validation or semantic validation. The fix is to validate the result against the required checks, return specific feedback, or escalate when validation cannot be resolved safely. These two failures may both look like the model got it wrong, but architecturally they are different. Different failure layer, different lever. Now use the evidence table as a ranking tool. If the trace shows tool use followed by final text, likely layer is loop routing. If the trace showing maximum tokens with partial content, the likely layer is token budget or continuation strategy. If the trace shows the wrong tool selected, the likely layer is tool boundary decision. If the trace shows valid JSON but wrong arithmetic, the likely layer is validation. If the trace shows repeated retries without new information, the likely layer is safe control. If the trace shows missing authorization, the likely layer is authority or permission flow. If the trace shows no useful evidences at all, the likely layer is observability. The table keeps you from changing the wrong layer just because a term sounds familiar. The output is wrong, so there is an issue with prompt. Maybe. But maybe the output is wrong because validation is missing. Maybe the loop ended too early. Maybe the wrong tool was selected. Or maybe the trace is too weak to know. Do not change the decision before the evidence names the layer. Now move to the course download pack. Open the trace review checklist. It is built around the same idea. Capture the smallest useful evidence set. Then prove the owning layer before changing the decision. Look at the first table. This is a trace snapshot. It asks for the case identifier or trace identifier, the request identifier when available, the response identifier, the stop reason, the content block types, the useful numbers, and tool signal, the validation signal, and the choose the next action. Again, we are not collecting logs for the sake of logs. We are collecting decision evidences. Now look at the second table. This table maps single to layer. You're trying to answer a decision question. Does the failure belongs to loop routing, to validation, tool decision, safe control, or now look at the lab 1 routing trace. We have response identifier, stop reason, tool name, customer identifier, and usage numbers. If the application returns final text here, the trace proves the loop branch is wrong. The issue is not the prompt, the issue is not retry, and not the schema. The owning layer is routing. Now look at the solution trace. The solution logs the environment, the request skeleton, response identifier, the stop reason, and the next action, and token budgets. These logs give us a reviewable chain from response state to application action. That is the point. The trace lets you prove why the application did what it did. Now compare lab 2. The fake first attempt has the right invoice, identifier, and company, but the total is wrong. One line item is missing. That is not stop reason routing problem. The response may look structured. The shape may look close, but the business facts are wrong. The trace should point to validation. The expected total is 16.20. There should be 2 line items. 1 line item is missing. So the fix belongs to validation and feedback, not to the loop routing, blind retry, or generic stronger prompting. Now connect this to the exam lens. Use this sentence pattern. The trace showed this signal. The owning layer is this layer. The best lever is this fix. I rejected that destructor because it changes a different layer. That one sentence is enough to turn debugging into answer ranking. The trace showed tool use, but the application returned final text. The owning lever is loop routing. The best lever is a stop reason router. I rejected stronger prompting because prompt wording doesn't own the loop state. Another example, the trace showed valid looking structured output, but the invoice total was wrong. The owning layer is validation. The best lever is semantic validation with specific feedback. I rejected routing changes because the router wasn't the failing layer. That is how you review scenario questions, not by memorizing words, by proving the layer. Ability signal, owning layer, smallest reliable lever. Your next action is simple. Use the trace review checklist Your next action is simple. Use the trace review checklist for the Lab 1 and Lab 2. For Module 2 review, use it to separate routing failures from retry failures. For Module 3, use it to separate schema shape from semantic validation. Later in this course, the same habit becomes reliability analysis. Read the trace, prove the layer, then change the smallest reliable layer. Read before changing. Trace first, lever second.